We're in section 4-4 looking at problem number 3 because Andy can't do the problem. That's bold if anybody wanted to know. And we find that f of t is g of t is sine t. And I don't have my my Tech Math book with me, which means we better open Maple to get some more integrals in case we need to. All right. So convolution says that, there we go. It says that f of t convoluted with g of t is equal to integral 0 to t f of tau g of t minus tau d tau. All right, so all we want to do is just find integral 0 to t sine t sine t sine tau t minus tau d tau. All right, so the first thing we have to do is remember what the sine of two angles subtracted from each other is. And assuming that no one has a trig book in the room, we'll have to go to Maple and ask, what is the sine of x minus y? Thank you very much. Expand. All right, so that's sine, cosine, minus cosine, sine. Now, I wonder how long it's going to take us to remember that. Sine, cosine, minus cosine, sine. Okay, so this is going to be integral 0 to t sine tau sine t cosine tau minus cosine t sine tau d tau. Sine, cosine, minus cosine, sine. Okay, so that's exactly what I have. Okay, so I'm at 0 to t, and then I've got sine tau, cosine tau, sine t. Sine t is not the independent variable, so it's just a constant. It can come out. Okay, then I got minus cosine t integral 0 to t of sine tau squared d tau. All right, so that's what I've got. Now, I remember from my trig class that the sine of 2 theta is 2 sine theta cosine theta. Is that what I remember? Am I remembering that right? So that means I can rewrite this as sine t integral 0 to tau of sine 2 tau divided by 2 d tau minus cosine t integral 0 to t sine squared d tau. Now, the integral of sine squared, what's the integral of sine squared? We'll go back to Maple again. So I want the integral of sine x and we'll put parentheses there, parentheses here, and a parentheses there. All right, that's what I thought it was. So 1/2 x, so that's going to be minus cosine t, 1/2 tau, minus 1/2 sine cosine, minus 1/2 sine tau cosine tau, evaluated at 0 and t. And then the integral of this guy, I'm going to have sine t. This is going to be minus cosine 2 tau over 4, evaluated at 0 and t. Okay, so did I do that right so far? All right, this is where I messed up. When I put this guy in, I put the t and the 0 over here, and I shouldn't have done that. So that's what I remembered over spring break. So this is going to be sine t times minus cosine 2t over 4, and then the cosine of 0 is going to be 1, so that'd be minus 1/4. But it'd be minus a minus 1/4, so that'd be a plus sign. Okay, and then on this side, I got minus cosine t. I put the t in, so I got 1/2 t. I got minus 1/2 sine t cosine t. When I put a 0 in, I get a 0 there, I get a 0 here, so the rest of that guy is 0. Okay, so now I got sine t minus sine t cosine 2t divided by 4 plus sine t divided by 4 minus 1/2 t cosine t plus 1/2 sine t cosine squared t. Okay. What am I going to do with that? I don't know. Then I'm going to do let's see, there's a sine cosine over 4. If I bring a cosine out of that guy, that doesn't help any. And a sine t over there, that doesn't help any. Am I done? Is that the right answer, or it has to be manipulated some more? Let's see, what am I going to do to manipulate that more, I wonder?
Do 1/2 sine t minus t cosine t. Yeah.
Okay, cosine 2t. I need a trig identity for that. Cosine 2 times x, and there's going to be more than one of them. Okay, so that's 2 cosine squared. So this is minus sine t, 2 cosine squared t minus 1 divided by 4 plus sine t divided by 4 minus 1/2 t cosine t plus 1/2 sine t cosine squared t. Okay. Now, right here I see a plus 1/4 sine t. Here I see a plus 1/4 sine t. So that means I've got a sine t over 2 between this term and that term. Here I have a minus 1/2 sine cosine squared. Here I've got a plus 1/2 sine cosine squared. They go away. I've got a minus 1/2 t cosine t left over. And there we go, final answer. Is that not right? Yeah. Yeah. So it can be done without a code book if you have manual. All right, next problem.
All right, can you go a little bit?
And like I say, the problem was when I was putting in the limits of integration, I was putting that 0 into that sine t there.
Okay, that's what I thought.
Yeah, that's what I was doing wrong. And well, once you do that, then you're just totally hosed.
Okay.
All right?
Yep.
Good enough? Back to the issue of what is the next problem.
Number 15.
Any particular section?
The one over here.
All right, so I've got f of t is t sine 3t. This is number 15, section 4.4. Okay, and in these problems, apply theorem 2 or 3. Well, isn't that nice? 2 or 3. So we'll look at theorem 2. Okay. Then I guess we'll apply theorem 2. So the Laplace transform of minus t sine 3t is going to equal the derivative of whatever that is. Okay. Now I had to put a minus sign there. There's not a minus sign here, so I'm going to have to put a minus sign here to compensate for that, so that I have a minus sign in the right spot. So f of t is sine 3t. F of s is going to be, what is f of s going to be? Is it 3 over s squared plus 9? Sine, yeah, 3 over s squared plus 9. All right, so now I've got to find the derivative of 3 s squared plus 9 to the minus 1. The derivative of that. All right. And then I'll worry about that minus sign later. So I'm going to take the derivative of this with respect to s. Okay, so I'm going to bring the minus 1 in front, 3 s squared minus plus 9 to the minus 2. The derivative of the inside is 2s. So I'm going to have minus 6s over s squared plus 9 squared. And then I'm going to remember that that minus sign has to go away, and it is a positive sign. So this would be the Laplace transform of t sine 3t. Okay, good enough?
Yeah, can you go up a little bit? How did you get the f of t equals sine of 3t?
It's sitting right there, sine of 3t, plain as day.
What happens to the negative t?
So on page 299, it says the Laplace transform of minus t f of t is equal to the derivative of the Laplace transform f of s. Okay, so f of t is sine of 2t. That I have a minus sign missing from this is interesting. So I have to put a minus sign in front of it to get it, which means I'm going to have to take it away later. Okay, and that's what I did. So I put a minus sign in front of it in order to be in the right form. And then when I got to the bottom, I took the minus sign away. Okay, good enough? Now let's look at Theorem 3. No, we're not going to use Theorem 3.
Can you have a little bit, please? Okay, can you show me how you got the f of t part? That's what, I don't get that part. From the formula.
All right, so I'm looking at page 299. And page 299 says Laplace transform of minus t f of t is equal to f prime of s. And we're given a function in our problem that says I have some problem f of t, and it's going to be t sine 3t. That being the case, that f of t sitting there is this guy sitting here, and the t sitting there is this guy sitting there, and the only difference is the minus sign. Yep. And now I got to deal with the minus sign, so I put the minus sign in so that I can do that. Once I do that, I take it out. Because the other thing I could have done is I could have said, well, the Laplace transform of t, f of t, is equal to minus that derivative. I could have done that too. And then I could have said, this f of t is sine of whatever, and this t is t sitting right there. I could do that too. And that's probably better.
Can you go back to the other page? And then the f of s right there is just off the Laplace transform sheet. Correct?
Yeah, you just took it right off the Laplace transform table.
Because it equals the derivative of the
Yeah, because I need the derivative.
Okay.
So I need the derivative of that guy with respect to s, because that's my independent variable. Okay, next problem. 19. Same section 4.4?
Yep, these are all in the same section.
So I got f of t is equal to sine t over t. And I'm doing the same thing. I'm using, either you're going to use Theorem 2 or I'm going to use Theorem 3. So those are my only choices. And I look at Theorem 2 and I say, well, I guess I can't do that. So that means I'm going to use Theorem 3, which says the Laplace transform of f of t divided by t is equal to the integral s to infinity f of sigma d sigma. All right, well, so that means that that guy is that guy there, and this guy is this guy here. So I need f of s, and that's going to be 1 over sine squared plus 1, s squared plus 1. So that's, I just take that off my Laplace transform table, number whatever it is, number 8. And then I go and say, well, the Laplace transform of sine t over t is equal to integral s to infinity 1 over sigma squared plus 1 d sigma. All right, well, I can't do that, so I have to limit b goes to infinity integral s to b 1 over sigma squared plus 1 d sigma. I recognize that as the arc tangent function, is it not? So I got limit b goes to infinity of arc tangent sigma evaluated s in infinity. Is that right? Again, if I had my tech math book with me, I could integral the arc tangent, integral blah blah blah. Yeah, I don't say. I'm pretty sure that's the case. And then, so we have limit b goes to infinity, and this is to b. And we have arc tangent b minus arc tangent s. Alright, so what happens to arc tangent as b goes to infinity? Is that pi over 2?
It is, yeah.
Yeah, pi over 2, yeah. I'm pretty sure it's pi over 2. So this is going to be pi over 2 minus the arc tangent of s. Okay, good enough?
What has 1/2 pi? That's the same thing.
What?
How do you know that the arctangent at infinity goes to 5 over half? By looking, would you have to look at a graph?
Well, I was grabbing my calculator, and I was going to go and look at 4,000. I'm going to look at arc tangent. Oh, bummer. Arc tangent of 4,000. And that's 90 degrees. That's close to 90 degrees, and I'm going to look at arc tangent of 4 million.
Okay.
And I'm getting closer to 90 degrees. So that's how I would do it. I'm pretty, as I remember it, as I remember the arctangent function, that would be the case. So the tangent function does this, and that happens at 90 degrees and minus 90 degrees. So as the arctangent function, as I go to infinity, is going to be 90 degrees, which should be pi over 2. So that's how I would remember that one. But I'd be hard-pressed to say, I have a Laplace transform that looks like that. Do an inverse Laplace transform on it. I'm not sure I'd want to do that. Okay, next problem.
17.
17, we just did 19. How can you have 17 after 19? That doesn't make any sense. I think you're just trying to see if I can not do one.
Well, I tried to do them and then I went back and did one after 19, except I did 19.
F of t is t e to the 2t cosine 3t. All right, and again, we have to do problems 2 or 3. Theorem 2 or 3 on this guy. So it looks like we're stuck with theorem 3 again. So theorem 3 says the Laplace transform of f of t over t is equal to integral s to infinity of f, what is that, sigma d sigma. Okay. So that being the case, my f of t becomes e to the 2t cosine 3t, and my f of s becomes what? Sine e to the, that's number 9 on my Laplace transform table, number 9, and I have k, which is the square root of 3, no, 3, so that'd be 3 over s minus 2 squared plus 9. Right, so that's how I get that. So now I want the integral s to infinity of 3 divided by sigma minus 2 squared plus 9 d sigma. All right, so how am I going to get that guy? Well, I don't have any really bright ideas. Let's see. If this were 3 over sigma squared minus 4 sigma plus 13, I couldn't factor that, could I? So that's a dead end.
Can we use the other formula, number 2, theorem 2, like we did on the first problem?
Yeah, but theorem 2 doesn't apply. Oh.
Because the t in front of it?
Oh, yeah, that's, yeah, this looks like it's a non-starter piece of crap thing here. So now you decided we're going to do it different. Okay, so we're going to do it different. I'm going to use theorem 2. So the Laplace transform of minus t e to the 2t cosine 3t is equal to minus f prime of s. Okay, and f of t is equal to e to the 2t cosine 3t. F of s is 3 over s minus 2 squared plus 9, and we want minus the derivative of that. What's the derivative of that? All right, so that'd be 3 times s minus 2 squared plus 9 to the minus 2 with a minus sign in front of it times 2 s minus 2 times the derivative of the inside. Okay, so that looks good. That minus sign goes away. So f prime s minus f prime of s. Okay, that negative sign goes away. 3, 6, 6. S minus 2. S minus 2 squared plus 9 squared. Okay, now what are we going to do with the minus sign? Okay, so that would be my final answer. All right. Next problem. No more problems?
Oh, no, I have no problem.
Okay. Well, that means we got to go to section 4-5. Section 4.5. Periodic and piecewise continuous input functions. All right, so
You got that one wrong.
what do you mean I got something wrong?
You think it's wrong?
Right.
Yeah, that's better.
Well, which one is it?
17. What was I still have a few questions about that one.
17. You think 17 might be wrong. All right, so I will see whether or not I think the author answer is the same as mine. 17. Well, I have an s squared minus 4s plus 13 squared on the bottom. But why don't I have that thing on top? So did I take the derivative wrong? This is to the minus 1, goes over there. 2 goes in front. That. Right. Okay. We'll try it again. Okay, so f of s is 3 divided by s squared minus 4s plus 13. Is that not what we have? Right. Plus 13. Yes, that's what we have. Okay, so I got f of s 3 s squared minus 4s plus 13 to the minus 1 f prime s minus 3 s squared minus 4s plus 13 to the minus 2 times the derivative of the inside 2s minus 4. I have minus 6s plus 12 over s squared plus 4s plus 13, the quantity squared. And I believe that that's perfectly okay. I don't see anything wrong with that. And is that not what I had before? Yes, exactly what I had before. Because I need a minus sign here, which makes this one plus and that guy minus. So now the issue is, how did the author get the wrong answer?
You have to do a product rule.
What product rule?
With the 3 and the other one.
No. Definitely not. All right, so we'll go to Maple. Okay, so we want the derivative with respect to x of what? 3 divided by parentheses, let's see, parentheses, x minus 2 squared plus 9. Is that not what we had? That's exactly what I've got. I think the author blew it. That's what I think. I think the grad student blew it. Yeah. That's my opinion. All right, next problem.
23.
You said you were done.
Oh, I said, well, with that little section, 15 through 22.
23. All right. 23. Oh, come on. This is so pathetic. When do you guys want to do it for Andy? And from number 2, the Laplace transform of minus t f of t is equal to that, which is equal to this. So minus t f of t is going to be e to the 2t minus e to the minus 2t, and f of t is going to be e to the minus 2t over t minus e to the 2t over t. Oh, that was so pathetic. I don't believe it. But if you didn't recognize that that natural log thing could be opened up into two things, boy, are you hosed. You never get the right answer. All right, good enough?
Yeah.
I left out some steps. That's okay, right? Yeah, that's all right. All right. Moving on to 4-5. Nope.
25.
25. You know I can't do 25. All right, 25. 25. You know I can't do any problem over 20. Oh, 25. That's pretty easy. Yeah. 25. What a piece of meat problem now. Here's 25. Natural log s squared plus 1 minus natural log s plus 2 minus natural log s minus 3 is equal to the Laplace transform of, well, not yet. So Laplace transform of minus t f of t is equal to f prime s. All right, well, this is the derivative of this guy is what? 1 over s squared plus 1, 1 over s plus 2, 1 over s minus 3. All right. So now I'm going to take the inverse Laplace transform of everything, and I get f of t is equal to sine t over t with a minus sign plus e to the minus 2t over t plus e to the 3t over t. And then I'd rewrite my final answer because I normally don't want a negative sign first. I go e to the minus t plus e to the 3t. There's a 2 sitting there. Minus sign t over t. Because I wouldn't want the first term to be negative. Spelling issue. Okay, good enough? Well, that was another pathetically easy one.
Can you go up a little bit?
Yeah, I might, yeah.
Um,
I thought it was going to be hard.
on the derivative of the first one,
Yeah?
there should be a 2 actually.
Shit, I didn't know it. No, it's too easy. 2s. So this is going to be 2 cosine t. Can't even take a derivative natural log over 2 cosine t. All right, there we go. Is that better?
Um, 28.
28? I don't see the trick in 28. 28. What are you doing 28 for? I'm going to give you guys the odd ones. 28 f of s
You can join that if you want.
Yes.
Either way.
s squared plus 1 cubed. Find the inverse Laplace transform. S cubed, huh? All right. So I do a partial fraction. A over s squared plus 1. B over s squared plus 1 squared. C s squared plus 1 cubed. And then I'd ask myself, is that the way I work that problem? Or am I blowing smoke? And I'm thinking that that's the way I'm supposed to be working that problem.
It does have to be like AS plus B on top.
Yeah, I'm afraid so. Yeah, I'm afraid we're going to have an AS plus B and a CS plus D and an ES plus F. Even if I did that, S squared plus 1 cubes. I don't have anything that's S squared plus 1 cubed. All right, well, bet a little bit of luck, E and F will be 0, and then I'll have a chance of solving the problem. Okay, well, that means I got AS plus B times S to the 4th plus 2s squared plus 1 plus CS plus D s squared plus 1 plus FS plus F has to equal S. Okay, so I got AS to the 5th plus 2as cubed plus as plus b s to the fourth 2bs squared plus b plus cs cubed plus cs plus ds squared plus 1 plus es plus f plus b is equal to s. Okay, I look at the s to the fifth term, and I get a is equal to 0. I look at the s to the fourth term, I get b is equal to 0. Look at the s to the third term, I get c is equal to 0. I look at the s squared term, 2b plus d is equal to 0, implying d is equal to 0. I look at the s term, I get a plus c plus e is equal to 1, implying e is equal to 1. And then I look at the unit term, and I've got b plus d plus f is 0, implying that f is 0. Isn't that helpful? That is just so completely, totally helpful. Okay. All right. I'm just so happy that I did that. All right. So what's my next thought on this particular problem? All right. So we're going to have to come up with a better method than that.
Does anything happen if you factor it out?
Factored it out? No, nothing would help there. All right, so where were we? Okay, so I've got s over s squared plus 1 cubed. All right, so my next choice is going to be, all right, I'm going to use that the Laplace transform of minus t f of t is equal to the derivative of the guy that I have. Okay, so f of s is equal to s, and I'm not going to write it that way, s squared plus 1 cubed. F prime of s is going to be s squared plus 1 to the minus 3 plus s minus 3 minus 3 times s squared plus 1 to the minus 4 times 2s times 2s. Okay, so f prime s 1 over s squared plus 1 cubed minus 6s squared over s squared plus 1 to the 4th. Isn't that lovely? Doesn't that just warm your little heart that I did that? I took the thing that was almost complicated and made it more complicated. I don't see where that helped me any. Does anybody get a warm fuzzy feeling about that helping them? No. Okay. So that being the case, we'll go to the next thing. And so this is no help. And changing colors, I have f of s is equal to 3 over s squared plus 1 cubed. Now, if I were to take if I could say that f of t is equal to t, the inverse Laplace transform of the integral s to infinity of f of sigma d sigma. Can I integrate that? Well, I can. Because I had Maple sitting right here, so I'll go and integrate. Can I go 0 to infinity on Maple? S to b. We go s to b of 3 divided by what? Divided by s. No, not s. Divided by. How come I'm not divided by? Divided by. Parentheses. X squared plus 1 raised to the cube.
What's your 3 on top?
Isn't there a 3 on top?
That's an X.
Oh, that's
S
it.
actually.
Yeah, okay, so I have to put an X on top. I don't know, I'm just writing things down here. Where? X. Oh. Okay.
So the F.
I don't know why the F is there. Stupid Maple, anyway. Didn't know I got rid of that guy. All right. Okay. Okay, that looks nice. Okay, well, we probably can. I don't know how we're going to go and. Can I? Yeah, I can do that. See if I can just copy it and paste it in the other guy. Alright, so is there really a 14 in front of this guy?
I'm the 1 more.
Yeah, they left out some of my stuff, didn't they? Stupid guys. Alright, so you're not going to let me cut and paste it. Alright, that's fine. So that means I'm going to have to remember it. 1/4. Alright, so I want limit b goes to infinity. And I'm going to have t times that. B goes to infinity of 1/4 b to the 4th minus 2b squared minus s to the 4th minus 2s squared divided by s squared plus 1 squared, s squared plus 1 squared, b squared plus 1 squared. Alright, so what are we going to do? b goes to infinity. We have a b to the fourth up here. We have a b to the fourth down there, right? And we have a b squared down here, and we have a b squared down there. Okay, so they're going to take each other out as I go to infinity. And all I'm going to have left is t over 4 minus s to the fourth minus 2s squared over s squared plus 1 squared. Okay. Now I want to take an inverse Laplace transform of that guy. Okay. So I've got t over 4, and I want the inverse Laplace transform of, I have an s squared on top, minus s squared, minus s squared minus 2, that's a plus 2, divided by s squared plus 1, s squared plus 1. Okay, we're going to move back up to here. B goes to infinity. That gets rid of that term. That gets rid of this term. But I still have a 1 sitting there. Well, that's 1 times him. Okay. So now the issue is, what do I do with this? Okay, it looks like I have to do a partial fraction. So if I go as plus b over s squared plus 1 plus cs plus d over s squared plus 1 squared. If I were to do that, then I would have as cubed plus as plus bs squared plus b plus cs plus d is supposed to equal minus s to the fourth minus 2s squared. At that point, I don't have an s to the fourth term, and I am hosed city. How hosed am I? Okay. Why don't I have an s to the fourth term? Right, so I took the interval x, so I did that right. Did I not? Did that right. These guys, wait a minute. Hold it, hold everything. B goes to infinity. Okay, let's relook at this guy. Okay, we're gonna relook at this guy going to infinity on us. Okay, so I got this guy going to infinity. Okay, so I got limit b goes to infinity. I'm going to bring out the 1/4. So I've got b squared divided by s squared plus 1 squared p squared plus 1 squared minus, that's b to the fourth, 2b squared divided by s squared plus 1 squared p squared plus 1 squared minus s to the fourth s squared plus 1 squared p squared plus 1 squared minus 2s squared s squared plus 1 squared p squared plus 1 squared. Okay, so that's what I'm doing. And I look at this guy and I see that this guy goes to 0. I look at that guy, I see that that guy goes to 0. All right. So I've got 1/4 limit b goes to infinity. All right. I'm going to multiply. Okay, I've got b to the fourth s squared plus 1 squared b to the fourth plus 2b plus 1 minus 2b squared over s squared plus 1 b squared plus 1 squared. This term goes to 0. All right. Now I'm going to multiply top and bottom by 1 over b to the fourth. 1 over b to the fourth. Okay. I'm going to get 1/4 limit b goes to infinity 1 over s squared plus 1 squared 1 plus 2 over b squared plus 1 over b to the fourth. This guy goes to 0, that guy goes to 0. And I end up with 1/4 limit. Oh, I don't have to take the limit anymore. I end up with 1/4 1 over s squared plus 1 squared. Now, what is that supposed to be? Limit. So here I'm taking the inverse Laplace transform of that thing. So I got a t in front of it is all I need. So if I put a t in front of it, this is my, no. I still have to take, I haven't taken the reverse Laplace transform yet. All right, so I still have to take the inverse Laplace transform of this, 1/4 inverse Laplace transform, and then put a t in front of it. Okay. So, that being the case, do I have an s squared plus 1 squared? And I do. It is number, no I don't.
Number 18.
Number 18 has an s on top.
Oh.
Yeah, that was exactly what I was thinking too.
Yeah, 18 is a constant.
Okay, number 20. Number 20. Okay, so I got a t, inverse Laplace transform. I'm going to want a 2 on top. So 2 s squared plus 1 squared 1/8. Okay, so I got a 2 on top. Okay, so this is going to, so f of t is t sine t minus t cosine t.
What's your 1/8 that?
I don't know. There's it right there. 1/8.
Alright, that's right.
F of t 1/8 t sine t minus t squared cosine t. Ta-da! I fooled everybody on that one. Fooled everybody. You didn't think I was going to get there, did you?
No, I didn't.
Yeah, you didn't. You didn't think I was going to get there. Yeah, indeed, a little faith. I mean, it only took 3 attempts, all of them bad. You always want to use the methods in the section you're in before you try to use some other method. Yeah, all right.
Now what about 27?
What about 27? 27, really? You guys are pulling my leg on 27. Because that looks pathetically easy to me. Okay, so f of s is equal to natural log 1 plus 1 over s squared. Oh, let's see. If I rewrote that as natural log s squared plus 1 over s squared, could I do that? Will that be okay?
Yes.
Yeah, that looks okay. And then I could write that as natural log s squared plus 1 minus natural log s squared. I can do that, right? And then I can take the derivative of it and come up with 1 over s squared plus 1 with an s on top. Just because Andy is going to make me he's going to make me do the whole damn problem and then tell me there's supposed to be an s there later on, 2s. And then minus natural log 2s over s squared. The derivative of the natural log of s squared is going to be this guy's on the bottom, derivative of that guy. Yeah, that's what it's going to be. So f prime s 2s s squared plus 1 minus 2 over s. Now, what is that derivative equal to? That's the issue. And so that's theorem number 2.
The first one is number 10 on the sheet.
And this is going to be the Laplace transform of minus t f of t. All right. So I'm going to take the inverse Laplace transform of the whole thing. So minus t f of t equals, I'm going to go way out and call this 2. And the other one looks like number 10. Is that what you're trying to tell me? Number 10. So that'd be 2 cosine t. So f of t, final answer, equals 2 over t minus 2 cosine t over t. Now that wasn't that hard. Compared to 28, 27 was dog soup.
All right, down 21.
21? Not sure to be done with this problem set already. Oh, look at that. All right. 21. F of t equals e to the 3t minus 1 over t. So t, f of t, is equal to e to the 3t minus 1. All right, now that I've done that, what do my theorems tell me? At least I'm not doing convolution. So theorem 2 says the Laplace transform of minus t f of t is equal to f prime s. Okay. I don't have a minus sign there, so I'm going to put a minus sign there, a minus sign there, and a plus sign there. And then that's going to equal 1 over minus 1 over s minus 3 plus 1 over s. What am I supposed to be doing here anyway? Find the Laplace transform. Okay. Alright, so I've got that f prime of s is equal to minus 1 over s minus 3 plus 1 over s. I'm going to integrate both sides of the equation, and I'm going to find that f of s is equal to minus the natural log of s minus 3 and I'm going to integrate that plus the natural log of s. I think I'm done. Where am I? Oh, no, I'm not done. Because I put the t over there.
Yeah, you're done.
Huh?
Yeah, you're done.
I'm done?
Yeah, ln s minus ln s minus t.
Why? Yeah, I misspelled it. Okay. Final answer. F of s, natural log s minus natural log s minus 3. Okay. I don't, yeah, I guess. Yeah, that'd be right. All right. Can I go on? Huh? 29?
Yeah.
29. Can anybody read? Is 29 in English? Oh, bummer. Tx double prime plus t minus 2 x prime plus x is equal to 0. We want to transform the given differential equation to find a non-trivial solution such that x of 0 is 0. I don't know what that means. But luckily, the instructor does have other resources he can call upon. And so file open.
Oh. What is it? That makes it real. They have like all oh, it didn't. Yeah. It like shows it instead of it's really cool. So it's convenient. So it's
Okay, we're in section 4.4.
yes.
And we're looking at problem 29. 29.
You don't have to have money.
Right. So none of you can read that, right? So you don't know what it's saying. Okay, so Tx double prime. And we look at theorem. Right, so we want the Laplace transform of this guy. So the Laplace transform of minus t f of t is equal to f prime of s. Okay, so if I take the Laplace transform of everything I see there, I'm going to have a minus x of s, s squared s of s, minus s x at 0 minus, that's going to be plus, that's going to be plus, x at 0, and I want the derivative of it. Okay, and then I want this guy, so that's going to be minus s, well, we'll go minus, we'll go plus, a minus s, x of s, plus x at 0, the derivative, minus 2 x s x of s minus x at 0 plus x of s is equal to 0. All right, so I'm using this formula defining the Laplace transform of that guy. So I have to,
One, is those supposed to be prime notation?
what, who, where?
So yeah, those.
These are both derivatives.
Okay.
Yeah, those are both derivative notation there. Right now, this guy is 0 as an initial condition. This guy is 0 as an initial condition. That guy is 0 as an initial condition. This guy, we don't know what he is.
Why is that?
Oh, because this is x prime. Oh, maybe not. Back. X at 0 is 0. Okay, so we know that so yeah, we know that this guy is 0 from our initial condition. We know that, but this is a prime guy. We know that this guy is 0. We know that that guy is 0. All right, now I'm going to take derivatives of things. So I'm going to take the derivative of this minus 2s x of s minus s squared x prime of s. The derivative of that guy is going to be 0. I'm going to have minus x of s minus s x prime of s. That guy's 0. I'm going to have minus 2s x of s plus x of s. All has to be 0. Now, assuming that I took those derivatives right,
You have negative qs of x, right?
here,
Yeah. Look at the one on the diagram. Look
Yeah.
at the first one. And that one in the black writing.
right here, minus 2. What are you looking at?
Here, go back down to the black one, after the purple one there. The first term, isn't that no twice?
This guy? No.
Yeah.
No, I got to take, this is minus s squared x of s. So I take the derivative of the first guy, s squared, times the function, minus the s squared guy times the derivative of the x of s guy. Okay? All right, so now we've got, what do we got? I don't know. I look at minus s squared minus s squared plus s x prime of s and then I'm going to bring these guys together. Those two cancel each other out. How did that happen? I'm taking the derivative. Those two cancel each other out. Boom, boom. And these two come up with minus 4s x of s is equal to 0. Right. So I've got x prime of s divided by x of s is equal to 4s over minus s squared plus 2. Is that a 2? 2. Is that an s squared plus s?
S. Yeah.
S squared plus s. Okay. All right, so I got x prime of s over x of s equals 4 over minus 4 over s plus 1. Do I not? I'm going to integrate both sides of the equation. I get natural log x of s is equal to minus 4 natural log s plus 1. Okay, so I have natural log x of s, natural log s plus 1 to the minus 4. I raise as powers of e. X of s is equal to 1 over s plus 1 to the 4th. Oh, yeah. Tell me I got that in my Laplace Transform table. Yes, I do. Yes, I do. Number 16 in my Laplace Transform table says x of t equals, number 16, t to the n minus 1, t cubed e to the minus t divided by 3 factorial. T cubed e to the minus t divided by 6. All right, am I right? Don't know? Am I right?
Yeah.
Yeah.
There's an integration factor in front of the middle. After you integrate it, they do a plus c because there's middle.
So there's got to be a plus c.
And then they did it.
Yeah.
They did it in front of it.
Yeah, plus c, plus c, plus c, 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 c. Yeah, I agree. All right. Well, I think we probably shot a perfectly good 2 hours, so it's probably time to quit while we're ahead. Oh, wait a minute. We got to look at how the author did this guy. And oh yeah, look at that. I don't believe it. He's got a C sitting there as well. And then, but he went and the C absorbs the 6 now. So final answer, x of t is c t cubed d to the minus t, because it's just part of that 6 becomes part of it. Okay.